Welcome to TopSolid 7. In this video, I'm going to walk you through a basic 3D milling sample. I'm going to start by importing data from my customer, and I'm going to show you step by step how to process it through completion using standard TopSolid 7, maybe some basic 2D operations, but mostly all 3D operations. Let's get started. Here I have a PureSolid file already present within my project, so I'm going to right-click on it and choose Convert Document. I'm going to go ahead and hit the green check mark to validate, and like that, TopSolid is going to import this PureSolid file. Now, once imported, because TopSolid detected there were multiple bodies, it made an assembly out of this, and this is just a silly little assembly of a dustpan mold. Pretty cool, actually. We have all sorts of machining that needs to be done on the cavity and core side. In this sample, what I want to do is I want to start by working on just the core side. So I'm going to flip this around until I get to the right part here. You can see I'm analyzing this with my preview down here. And now I'm going to send this into machining. I'm going to go ahead and right mouse button click and just choose machining. For this sample, I'm going to use just a blank template. This is just to illustrate some of the out-of-the-box power that TopSolid 7 offers. To begin with, I'm going to use standard block stock, and I'm going to hit the green check mark. Now TopSolid wants to know how I want to position this part. Now if you look, it looks okay to me. It's relative to my X and Y axis, but maybe I want to flip this to have the longer part of my part relative to the X axis. Well, to start with, what I'm going to do is select my face, select my plane. The plane in this case representing the table of our CNC machine. From there, I'm going to take this face here and then select the X axis. By doing that, it applies a constraint type called plane on axis. Now, if you want to finish constraining, you can always do the left face there or the right face onto the plane there. There is a ton of different constraint types here thanks to TopSolid design. Once positioning is complete, I'm going to go ahead and validate my positioning group. Like that, TopSolid makes my stock block, and it even defines my G54 at the top center of my part. Now, to begin with, we want to start roughing this data. So what I'm going to do is go select a face here, right mouse button click, and just choose roughing. The very first step here will be to select a cutting tool. To do that, I'm going to come over here to my tooling selection. My tool choice wizard is going to pop up, and for this case, I'm just going to use a standard end mill, and maybe we'll build the end mill on the fly together. So to do that, I just double click on slot mill. And now here it's asking me for a diameter of tool. I'm going to say, how about a 3/4 inch end mill? That looks pretty good. How about if I say 1.5 inches worth of flute, maybe under the advanced section here, I want to make sure it's a 4-flute cutter. Perfect. Over here, I'm going to say it's a 3-inch total length tool. Shank is 3/4, that's fine. If I click to here, I can control that extension. So maybe this extension is 1 3/8, and maybe it is, a 3-inch long extension. And you can see every change you make will update the design of the tool. Finally, I can go to the assembly side, and I can play with the gauge distance of the tool, and that means how far that tool is sticking out of the holder. Maybe to start with, I'm going to start with 1 5/8 inches. Perfect. Up here, I'm going to call this my 3/4 inch end mill. Good enough. That's just the name of my tool. Now, the next thing we need to do after we select a tool is we need to set some feeds and speeds. So let's go ahead and do that. I'm going to come into my feeds and speeds here, and I'm going to look at this. And here, when I look at my feeds and speeds, it's picked something from my database. I'm going to say I disagree with it. I'm going to say, you know what, I want this to be at 5,500 RPM, and I want to have a chip load factor of about 5 thousandths. And as you can see, it's calculated from the definition of my tool that at 5,500 RPM at a 5 thousandths chip load, I'd have to be at 110 inches a minute, which is perfect. From here, I'm going to activate jet coolant, and that's it. Now I'm just going to click OK. Now, what TopSolid is going to do is it's going to take the tool, the cutting conditions, and all of my default values that I have set within my solution, and it's going to calculate our cutting path for us. Here you can see the tool comes down, and it's into this light simulation mode. Now, right now I have my little simulator minimized. I'll go ahead and pin that up so we can see it. And like that, you can see that there's a little bit of a control simulator here. I can zoom up. I can hit my plus and minus key to speed up or slow down the simulation of this tool path. But at the end of the day, it's doing a reasonable job of removing that material. Now, I can exit out of here, and maybe I want to go look at this within Verify. So I'm going to right-click, go to Verify. I'm going to hit Play in that simulator. And here again, that tool is going to come down, and now you're going to see the material removal. Now here I'm just using standard roughing. I could use voluminal style machining as well, or adaptive feed rate toolpath as well. The choice is, of course, yours within the TopSolid family of products. Now, maybe all I want to see at the end of the day is, are there any collisions? So let's go ahead and watch turbo mode. And here in turbo mode, you can see the end result really, really fast. And you can see that there's no collisions. But how are you sure there's no collisions? I'm sure there's no collisions because my collision icon here is still grayed out, which means the solution has not found any collisions whatsoever. Now, if we look at this, our 3/4 inch tool that we used here probably is not going to be able to machine everything into here perfectly. So maybe what we want to do is copy and paste this and just change the cutting tool. I'll show you what I mean. I'm going to go here, pick pocket number 2. Again, I'm just going to use the standard end mill, but in this case, instead of making a new one, I'm going to ask the solution to look through my database to see if I have what I need. So to do that, just a couple choices. I can right mouse button click and choose New Tooling from Catalog, or you can just double left click right on the empty pocket. Here, TopSolid is going to load a list of all available cutters. I'm going to go into here and say, how about we look for a 3/8 diameter end mill? Let's have a look. That one looks perfect. I'm going to go ahead and green check mark. Again here, all I'm going to do is hit OK. What's really cool here is that the software is just going to continue roughing where the bigger 3/4 inch tool couldn't. I mean, think about that. You've seen me create a bunch of toolpath by selecting a piece of geometry, selecting a tool, and hitting go, basically. But now what I want to do is I want to analyze how the software knows all that. Teach you guys a little bit more. So if I go into my first roughing toolpath, I can go either into my full settings here, or I can pay attention to my quick settings balloon over here. In the quick settings balloon, what's really cool is you can make quick modifications to common settings. For example, my axial depth of cut, or my depth of cut in Z. I'm taking a 300 thousandths depth of cut by default. Cool, I'm leaving 30 thousandths of stock on the floor and on the wall, and my calculation tolerance is at about a 3 thousandths tolerance, which is good enough for roughing. If I go into my full settings here, now I have access to every option whatsoever within the roughing routine. Here I'm taking a 40% step over. There's that stock to leave again. If I go to my altitudes, there's my axial depth of cut. Notice here there's an equal sign though, and what's really cool here is I took the time to teach TopSolid a little bit of how I like to machine parts. If I click on here, you can see that it's showing an equation. That's this equation in this case is me dot cutting length times 0.2. And what cutting length is the variable for the flute length of the cutter that we described, and we're multiplying that by 20%. Pretty cool. It just gives you a way to capture some of your manufacturing knowledge and teach TopSolid CAM how to use it. Now, from here, we have our re-roughing. And the re-roughing, again, think about it. All I did was change the cutter, right? If I go into the same settings and I go look at my altitudes, I have a completely different value. Same equation, it's just a different value because it's a different diameter tool with a different length of cut. Pretty neat. Now, from here what I'd like to do is I'm going to right-click and hide my stock because I just want to make it easier to see what I'm looking at. And now I want to start semi-finishing this part. So to do that, again, I'm going to select a face. And the reason I'm selecting a face, by the way, is by selecting a face, I'm selecting the deepest point that we're going to cut to dynamically. So if I go to finishing, for example, you'll see my planes pop up, and they're popping up roughly to the bottom-most Z of the face selected. It's kind of a neat little magic trick. You can always move that down or up and play with this as you want, type the value in that you want. Here I'm going to go, again, grab a tool. Let's go up here to ball nose. Again, I'm going to look in my library to find a specific ball nose cutter. And to start with, I want to start with maybe a 1/2 inch ball nose. That makes sense. Maybe 1 inch of flute. Cool, I like it. I'm going to green check mark. And now here, the only thing I'm going to do is set some feeds and speeds and the stock to leave. So here, yeah, why not? 6,000 RPM looks good to me. Let's maybe go into here and say it's a 2,000 chip load at this point. We don't want to go too fast. Pop that back over there. And over here, I'm going to use my quick settings balloon and say, okay, I want to bring my stock within, let's say, 10 thousandths. 10 thousandths on Z, 10 thousandths on the wall. And I want to do this at a scallop height roughly of about 2 thousandths because this is just a semi-finish. That's it. I'm going to green check mark. Now here, TopSolid is going to apply a raster pass, but again, I have some default values set. So when it makes that raster pass is going to have all of the cool features that TopSolid handles turned on and activated and set to calculate appropriately based on the tool selected. So here you can see I'm doing a nice little smooth move, little raster pass just to semi-finish this thing, knock everything down. You have nice clean dogleg loops. Anywhere there's a sharp corner, we have filleted the tool path if possible, just to make it even smoother motion. And again, all you had to do was pick a tool and hit go. If I was to take all of this information and go ahead and send this into Verify, so I'm going to right click, go to Verify. From there, I'm going to go ahead and hit Start Result. Because again, that's that turbo mode. At the end of the day, all I want to see is what it's done, what it needs to do. And here you can see exactly what that tool could reach, what it couldn't reach, where there's still material left. Everything is right in front of you. Kind of cool. Let's keep going. Now what I want to do is I would like to begin finishing all of this. Why not? So what I'm going to do is I'm going to right click on this face here. I'm going to go to finishing again, but this time I'm going to use a bullnose tool. So let's go find a radius mill and let's go see what we can do. I'm going to look for something that has maybe a 1/2 inch diameter and maybe with a corner radius of a 1/16. I like that. Perfect. And now what I want to do is I want to change the type of cut. So I don't want it to be a raster pass. I want to be a constant Z tool path. Kind of cool that you can just change from one to the other. But you know what? I want to use similar cutting conditions. So what I want to do is I'm going to take my raster pass here. I'm going to drag and drop it right onto my cutting conditions. Cool. From there, I'm going to look at the stock to leave on the floor and on the walls. That's perfect. Maybe my scallop height, maybe I'm going to make that a little bit tighter. I'm going to say that this is going to be a 1/2 thou. And like that, we'll click OK and let's see what the software comes up with. Now, one of the beauties of TopSolid 7 is that we have created what's called a multi-core engine. So all these toolpaths are calculating really, really fast because I'm using all the processing power of my computer. Some of the solutions out there still only use 1/2 of one core, so you're still waiting for some of those calculations to be done, and I've created already 4 toolpaths at record speeds. If I look at this now, you can see that Z-level finish has attacked everything that a Z-level finish can pick up. Kind of neat. But you know what? It's a bullnose cutter, so why not try to pick up all the planar faces as well? That way we get the best blends of all worlds. So let me show you what I mean. If I go into here and I go to Settings, I can then go to Strategy, and I can say, you know what? I would like to activate planar area machining at this XY step over. Being that we're just cutting pixels in a demo, I'm going to change this to be a little bit bigger step over. You'll get the idea. Everything else I'll leave as the way it is. I'm going to click OK. So now it's going to calculate again, but this time it's going to pick up every single planar face that it can with this tool, and it's going to finish all of those faces too. Again, trying to keep that tool path as smooth as possible to keep transitions nice and clean. We're even helically down onto faces when we need to, and everything is good. If I go and look at all of these tool paths now, or you know what, let's do it this way. Maybe I want to verify just this tool path, right? But maybe what I'd like to do is verify it in animation mode. If I did that here right now, you have the problem of this is going to come down, but this is going to start cutting based on it being already roughed out, which is hard to tell if it's doing the right thing. So thankfully, TopSolid has your back here too. What you can do is you can right click on any part within Verify, and you can say I want to update the stock. I want to update the stock with all of these in rapid mode. So now my stock model is getting updated in rapid mode based on all those previous operations. And now I can come in and hit play and watch animation mode. Again, that's if you want to use animation mode. It's just to show you that you have lots and lots of options within the TopSolid family of products. Now, in this case, because we've all seen animations before, I'm just going to watch turbo mode because I just want to see what it can get to, what it can't get to. Pretty neat. Now we're getting somewhere. The part is getting closer and closer and closer to a good finished part. But we still have work ahead of us. So now, why don't we try to deploy some rest machining? The next thing I want to do here is quite simple. And again, right click here, and I'm going to start by going into Material Left Machining. In this case, what I'd like to do, I'd like to go change tools. I'm going to go pick a different tool, a ball nose mill in this case. And in this case, maybe we want to have 1/4 inch. Let's try that. That looks good. And for this first rest machining, what I want to do is I want to change to constant radius machining. 8/10. We're going to say the previous tool, I'm going to lie about it and say it was a little bit more than 1/2 of an inch. That's it. I'm going to hit go and let TopSolid do the rest of the heavy lifting for us. And in this case, the solution is going to automatically try to continue machining where the tool of that size could not reach. And if you remember, these are all the areas where it was showing there was still material. Now, if I zoom up on this toolpath, you're going to see that these toolpath algorithms are really, really smart. These are shallow, so it's nibbling in a very smooth way into these corners. Okay? And if we look around here, this is a steep condition. So for the steep condition, it's doing a helical type of a cut down the corner until it gets to the point where it's shallow again, and then it's doing a constant spiral cut in on the corner. But this is just showing you some really, really powerful toolpath algorithms that we've applied with next to no input on our side. Again, the idea here with TopSolid is to allow you to capture some of that manufacturing knowledge and teach TopSolid about it, and then deploy it so that all the users on your team that are programming parts of TopSolid can program parts more efficiently and with greater ease. And I mean, that's the trick, isn't it? We want to speed up production while still getting a good quality result and allowing our programmers to focus on stuff that maybe is a bit more challenging to program. Stuff where you really got to be creative, things like that. That makes sense for you to dig in, play with settings, and mess around with the software. But if it's just a simple part, shouldn't you be able to bang that out relatively quickly? And we think the answer to that question is yes. I hope you enjoyed this short little demonstration of TopSolid for 3D machining. Check back soon for further details on some of the other toolpaths that we support.